Good morning, grade 11s. It is bright and early this morning. I have some stuff I have to take care of around the time I would normally be recording your video. So, I'm recording it early for you. Let's go. Alright. So, these are the answers to the last couple of questions I gave you. I left you right there. So then you run that through the quadratic formula and you get 24 and 11. Because that should say the square root of 169. There is number 4. So the length was decreased by x, the width was increased by x. Length times width equals 378. You do the math, you collect the like terms, and you turn it into a quadratic equation, which factored. So you found that x was 5 and 2. So if x was 5, then it's going to be 23 minus 5, which is 18, and 16 plus 5, which is 21, or 23 minus 2 is 21, and 16 plus 2 is 21, so 18 and 21 have to be the new dimensions. And then this one, you will notice up here, it's just in the wrong order. So all you had to do was take that ABC, just put them in the right order, and run it through the quadratic formula. Now, because it didn't come out perfectly, we used our calculator. And we knew it couldn't be this one because that would have given us a negative answer. And a ball cannot be in the air for a negative amount of time, so it had to be that one. Alrighty. And I think that's all I left you with. Now, what I will do is show you this little review that I have right here for solving a quadratic equation. Always try to factor it when you can, because that might be enough. When you're completing the square, if this b is even and a is 1, completing the square is pretty good. But if you can't do either of those two, you can quadratic equation. And remember, you can always quadratic equation to find the actual answer. But you want to be able to do all 3 of them because we use all 3 of them in further math. Now I've got a 4th one here, graphing calculator. But because not everyone has a graphing calculator, we won't be spending any time with that. All right, so we move on today to pages 92 to 95. Yes. All right. Oh, sorry, everybody. So, let's have a look here. You can see that I've asked you to solve all of those equations with the quadratic formula. So let's do that. It will not take long, have no fear. We are not going to do all of this. We're not going to use a graphing calculator to solve these. So, but let's have a look. So in the first one, we've got an A, a B, and a C. So all we do is run it through. Now, I know that you know that all of a bunch of these are factorable, but there's something I want to do with the quadratic equation that I want you to see. So we're going to use the quadratic equation for all of them. And quite frankly, most of you would probably rather use the quadratic equation anyway. So, sorry. And when I say quadratic equation, I mean the quadratic formula, of course. So let's rewrite that right here so we can see it. X equals negative b plus or minus the square root of b squared minus 4ac over 2a. So let's run that first one through it. That's 8 plus or minus the root of 64 minus 4 times 1 Hakian times 16 over 2, which is 8 plus or minus the root of 0 over 2, which is 4, right? Because 8 divided by 2 is 4. Okay, let's look at number 2. Number 2 is 12 plus or minus the root of 144 minus 4 times 4 times 9, all of that over 8, which of course will give us 3 over 2, because, oh, well, I'll show you why. 12 plus or minus the root of 0 over 8, which gets us 3 over 2, because 12 over 8. And lastly, number 3, that gets us negative 10 plus or minus the root of, I'm running out of room here, so that is 100 minus 4 times 25 times 1, which you can already see is negative 100 over 50. So that's negative 10 over 50, which is negative 1/5. All right, now let's look at number 2, which I'll do in a different color. I'll slide it over here slightly. Number 2 we'll do in blue. Number 2 is negative 5 plus or minus the root of, you run it through the quadratic equation, and you get 25 plus 42 over 2. So you get negative 5 plus or minus the root of 67 over 2. Now, 67 is a little bit more than 8, right? So you got negative 5 plus 8, which is about 13 over 2 approximately, right? That's what that symbol means, approximately. And negative 5 minus, sorry, I screwed that up. Negative 5 plus 8 is approximately 3 over 2, and negative 5 minus 8 is approximately negative 13 over 2. Now you do the same thing for number 2. And number 2 ends up being 8 plus or minus root 52 over 12. Root 52 is approximately 7, so you end up with approximately 8 plus 7 over 12, 15 over 12, and 8 minus 7 is 1 over 12. And number 3, when you do all the work, because you don't need to do it all, I know that you can plug stuff into an equation. You end up with 3 plus or minus the root of 89 over 10. Now the root of 89 is almost, it's like halfway between 9 and 10, so we'll call it 9.5. So 3 plus 9.5, you end up with 12.5 divided by 10, and negative 6.5 divided by 10. And number 3, which we'll do in green, you end up with negative 3 plus or minus the root of 9 minus 24 over 2, which gives you negative 3 plus or minus the root of negative 15 over 2. Hey, is there any such thing as a square root of a negative number? No. So this has no solution. Then we'll look at number 3. I've been numbering these. They should all be lettered, of course. That's A, B, C for number 1. And that's A, B, C. So this is B for number 3, which I'm doing in green, which is 4 plus or minus, and that ends up being negative 24 over 4. Hey, no solution. And number 3, or C, ends up being negative 2 plus or minus the root of negative 12 over 8. Hey, no solution. Now, the question that I ask you here is, do you notice any patterns? Well, what did you see in the first one? One answer, and one answer. What did you see in the second one? 2 answers, 2 answers, 2 answers. What did you see in the third one? No answer, no answer, no answer. Now, if that's the case, there must be a reason that happened. Well, I call your attention to this. Square root of 0, square root of 0, square root of 0, square root of 67, square root of 52, square root of 89, and finally, a negative, and a negative. So you will notice that whatever is under the square root sign tells us how many answers we're going to have. Under the square root sign is b squared minus 4ac. Now, you can see right here, if that equals 0, we get 1 root. Now, this is a little weird. We get 1 root for an answer, but really we get b squared, really in the final answer we have negative b plus or minus root b squared minus 4ac, right? So if that's 0, what I really get is negative b plus 0 and negative b minus 0. So what happens is I actually get 2 equal roots. So they appear to be one root. One root. Now, what does that mean for us? If I were to graph this, the parabola would come down, and I'll graph it in a different color. The parabola would come down, and it would hit the x-axis once. Two equal roots that appear as one root. Now let's look at the green one. Now I highlighted it in green. I should have highlighted it. I should have done this one blue and this one green, but it's early and I'm a dummy. In this one, b squared minus 4ac was greater than 0, so it was positive. Well, you can see we get two roots. So what this guy would look like, I'm going to highlight this as yellow because all this is the yellow rules. This guy that I'll highlight in green would look like this. See, it would hit x twice. So that's all the green stuff. This is number 1, this is number 2, and then obviously number 3, which I wrote in green but highlighted in blue because I'm an idiot. B squared equals 4ac can also be less than 0, which is negative. And that gave us no solution, no roots. So that would look like this. It would never touch the x-axis. So that is number 3. Okay? Now, let's turn the page over. This right here, that part, there's all those rules we just wrote down. That part, b squared minus 4ac, is called the discriminant. Because it discriminates in the quadratic formula if my parabola is going to be this, bouncing off the x-axis, or this, touching it twice, or this, never touching it. It discriminates. So, I got 2 questions right here. Let's check them. A, 9x squared plus 6x plus 1 equals 0. I want to know the nature of the roots. Remember, I have 3 options. There's either going to be 2 equal roots, which means I end up with 1 answer, 2 different roots, which means I end up with 2 answers, or 0 roots, which means I end up with no answers. Now, please notice I am only asking for the nature of the roots. I don't need to know what the actual roots are. So we only need the discriminant, which is b squared minus 4ac. So let's check it. Right in here, there's a, there's b, there's c. So b squared is 6 squared minus 4 times a, which is 9, times c, which is 1, which equals 36 minus 36, which equals 0. If the discriminant is 0, 0, that's that one. So I have 2 equal, now let's write it out, 2 equal roots which means it would appear on the graph, appears as one number. B. 3x minus 5 equals 4 over x. Now we look at that and we say, hey, Myers, that's not even quadratic. There's no x squared. We can't even do it. But we can. We have to make it look like this. So what here bothers us? Well, you should all be saying this fraction bugs you because there's no fractions in the quadratic equation or in a quadratic equation. So how do I get rid of divided by x? Right now, all of you should be yelling at your screen. You multiply by x, Myers. If I multiply the right side by x, I multiply the left side by x. X times 3x minus 5 gets me 3x squared minus 5x. X times 4 over x, the x's cancel, and I get 4. Now, I have 3x squared minus 5x minus 4 equals 0. And there is my A, B, C. So all I do is I run that through the quadratic formula, or through the discriminant, because I only care about the discriminant. That is going to be negative 5 squared minus 4 times 3 times negative 4. Right? Which gets me 25 minus, what's 12 times negative 4? Is negative 48, so minus negative 48, which is 25, plus 48, which is 73. My discriminant is greater than 0, so that's this one. So I will have 2 roots. Okay? And that's about it for concepts here. So let's show you how we can play around with this. So for example, this one, I don't know B. B is a question mark, but I want it to have no roots. If it has no roots, that means b squared minus 4ac has to be less than 0 or negative. So let's have a look at that. B squared, B is P, right? So P, negative P squared minus 4 times 1 for A and 25 for C would have to be less than 0. Negative P squared is P squared. 4 times 1 minus 4 times 1 is 4. 4 times 25 is 100. Would have to be less than 0. Bring that over here. P squared would have to be less than 100. And then how do I solve this? I take a square root. P has to be less than plus or minus 10. Now, in the 9th grade, you dealt with these. You haven't dealt with them since. That's how we teach math. We teach you something, and then you think you got it. And then 2 years later, we come back and we mess around with it. It's not your fault, it's our fault. But what are you going to do? So P has to be less than negative 10, or P would have to be greater than positive 10. Excuse me. Right? So, find the values of P. This means that any number less than negative 10 or any number greater than positive 10 will ruin that equation. It won't ruin it. It'll make it look like this. It'll never touch the x-axis. It'll either be a parabola going up or a parabola going down. So here's one for you to try. You should try it right now. I'm going to pour myself a cup of coffee while you try it. I'm just going to pause this. Okay, we're back. So it's the same thing. If it wants to have two different real roots, then k squared minus 4 times 2 times 3 would have to be greater than 0. So k squared minus 24 would have to be greater than 0. So k squared has to be greater than 24. We take a square root, so k would have to be greater than plus or minus root 24, which, you're smart kids, means k is either greater than root 24 or k is less than negative root 24. Now, some of you say negative radical can't work. The negative sign can be outside the radical, just can't be under it. So this is about 5, right? So let's call it 4.9. So that means k would have to be greater than 4.9, or k would have to be less than negative 4.9. Oh, what if... Garumph. Greater than. Because see, greater than. Greater than. Okay? All right. So find the value of the discriminant. This won't take very long. I don't really think we need to worry too much about it. The discriminant is 5 squared minus 4 times 1 times negative 3, which is 25 plus 12 is 37. It's positive, so 2 roots. B, that's going to be 4 squared minus 4 times 2 times 1, which is going to be 16 minus 8, which is going to be 8, which is positive, so 2 roots. C, that's going to be 1 minus 4 times 5, which is going to be 1 minus 80, which is going to be negative 79. Negative, so no roots. And D, that's going to be 64 minus 4 times 1 times 16, which equals 0. So 2 equal roots, which really means 1. Other way around, actually, it's 1 root, but that really means 2 equal roots. A, B, C, D, this is exactly what we were just working on, but you'll notice the P has moved around. It's the exact same thing. All you do is work it out. We remember that, 16 minus 4 times 1 times P to have 2 different real roots. So B squared minus 4AC has to be greater than 0. So that would have to be greater than 0. And then we just solve it. 16 minus 4P has to be greater than 0. Minus 4P has to be greater than negative 16. Divide both sides by negative 4. And again, this is something from the 9th grade we have to remember. When we divide by a negative, we flip the sign So p has to be less than positive 4. So any number less than positive 4. And then b, p is right there, so it's 25 minus 4 times p times 2 would have to be greater than 0. So 25 minus 8p would have to be greater than 0. Negative 8p would have to be greater than negative 25. P would have to be less than 25 over 8. And C, p squared minus 4 times 1 times 8 have to be greater than 0. P squared minus 32 would have to be greater than 0. P squared would have to be greater than 32. So P would have to be greater than plus or minus root 32, which means P, that's all I care about. And D is the hardest one by far, so I'm going to erase C, and we're going to plug D in right there. That's going to be, now this is weird, right? Because B is weird. So 3p squared minus 4 times 1 times 1 would have to be greater than 0. So 9p squared minus 4 would have to be greater than 0. So 9p squared would have to be greater than 4. P squared would have to be greater than 4/9. So P would be greater than plus or minus 2/3. And we can stop there. Now this question is the exact same, except I want it to have no real roots. So b squared minus 4ac would have to be less than 0. So I'm going to leave that to you guys to try that out. All right. Actually, you should be able to do the rest of these. You got a lot of work this weekend, though. Let's just go ahead and do them. It's no big deal. That's got to be 36 minus 4 times 1 times m would have to be less than 0. 36 minus 4m would have to be less than 0. Negative 4m would have to be less than negative 36, so m would have to be greater than 9. B, 5m squared minus 4 times 1 times 25 would have to be less than 0. 25m squared minus 100 would have to be less than 0. So 25m squared would have to be less than 100. M squared would have to be less than 4, so m would have to be less than positive or negative 2. Now this is where it gets weird, but what you really have to do with this one, and actually what you had to do with all of these other ones, I should have done this, I wasn't thinking, you really need to check it. So here's our number line. There's 2, negative 2. There's positive 2. Right in the middle is 0, right? So the best way to check this is to check it with 0. So if m equals 0, that's going to be x squared plus 25, right? Because if this in here, check with 0. So if we say m is 0, that's going to become x squared plus 25, which means x squared equals negative 25, which can't happen, no real roots. So 0 doesn't work, so that means nothing in that section will work. So really, m would have to be greater than 2 or less than negative 2. That's really how you have to do the questions that end up like this. And I kind of forgot to do that up there. I'm really sorry. So, well, you'll see it again down lower. And I'll do that again. C, oh, sorry, I changed color. No big deal. C is going to be 64 minus 4 times 3m times 1 would have to be less than 0. 64 minus 12m would have to be less than 0. Negative 12m would have to be less than negative 64. So m would have to be greater than 64 over 12 is 16 over 3. And D, we'll put right here. This one's really tricky, right? Because B is a mess. It's 6x plus m, right? So that one's really hard. But we can do it. B squared is going to be what there? That one's really tricky. Pause. Nah, screw it. We can work it out. Well, think about it for a minute. Where does it make sense to work with this? What do I have? Well, let's look. Do I have an A? Yeah. Do I have a B? Yeah, I got a solid B. So that becomes my C. So now it's no big deal. B squared is 36 minus 4 times 1 times m minus 3 would have to be less than 0. So 36 minus 4 times m minus 3 would have to be less than 0. So 36 minus 4m plus 12 would have to be less than 0. So 48 minus 4m would have to be less than 0. Negative 4m would have to be less than negative 48. So m would have to be greater than 12. And then we're good. And lastly, we'll do this one. If it has two equal real roots, b squared minus 4ac has to equal 0. So a 100 minus 4 times 1 times k has to equal 0. 100 minus 4k has to equal 0. Negative 4k has to equal negative 100. K equals 25. B. 9 minus 4 times 2 times k has to equal 0. 9 minus 8k has to equal 0. Negative 8k has to equal negative 9k has to equal 9/8. C. 4k squared, because this is B. Minus 4 times 3 times 5 has to equal 0. 4k squared minus 60 has to equal 0. 4k squared has to equal 60. K squared has to equal 15. So k has to equal plus or minus the root of 15. And C, oh, sorry. What have I done here? A, B, C, right. D. D is gross. Why is D so gross? Because there's 2 k's, but it's no big deal. Because 4k squared is 16k squared minus 4, looks like 46. 16k squared minus 4 times 1 times negative 3k would have to equal 0. 16k squared plus 12k would have to equal 0. Now, you're smart kids. Do the math that you know that factors. Take out a 4k. 4k times 4k plus 3 would have to equal 0, which means k would have to equal 0, or k would have to equal negative 3/4, because you would solve both of them. Because, sorry, I'll do it this way. That means 4k would have to equal 0, which would mean k would equal 0, or 4k plus 3 would have to equal 0. 4k would have to equal negative 3, so k would have to equal negative 3/4. Alrighty, now I am going to leave you with that question, and now listen carefully. By Sunday night, and I'm going to write this down over here so everyone can see it. By Sunday at 11:59 p.m. So that's midnight on Sunday, which is technically Monday, but you know what I mean, you crazy kids. You need to have all quizzes done, including the one that's going up today. So that's quadratics quiz, quiz 1 to 4. And your other bit of work is this page here, the practice test, page 96. Do the practice test which is pages 96 to 97. Where am I working here? Right there. 96 to 97. Now, some of you will be questioning, hey, Myers, what about pages 88, 89, 90, and 91? What are you talking about? What about those ones? I would want you to do these. You don't have to do all of them, but you should find some factorable ones, find some complete the squares, and find some formula ones. Do a couple of each. I know I said do the complete the square 5 times, but how about we do it this way? Factorable ones. Let's say the factorable ones will be yellow. So let's say that one factors, that one factors, that one factors, and that one factors. Do those 4 for factorable. Let's complete the square. Let's complete the square. Where can we complete the square? Let's complete the square on 8. And let's complete the square on... There's another one I like for completing the square. Let's complete the square on 10. So you're going to do, there's factor 3, 4, 7, and 8. 3, 4, 7, 8. Complete the square on 10 and 16. 10 and 16. And then for the formula, just do any... Now, I better give you some because I only want to show you the answers to a few. Let's do the formula on 14, not 20, 14, 20, and 24. Do the formula on 14, 20, and 24. And that should take you through. I'll show you those answers on Monday. Now, if you haven't been keeping up with the quizzes, that seems like a lot of work. But you were supposed to be keeping up with the quizzes. So, meh. All right. We'll see you guys back here. I'll have another video for you Monday, and then we'll have a meeting on Tuesday. Okay? Have a great weekend, you guys. And not a word of a lie. I hope that we can see each other again because I miss class. Talk to you soon. Stay strong, stay healthy, stay together.